everyone, welcome back to my channel Tutelage, a guide to learner. Here, this is Sriparna. Hope all of you are doing good. So, in my last session, we have already discussed the measures of dispersion, part 2. So, today we are going to explain another some new concept under the same chapter. So, that's why it is called measures of dispersion, part 3. So, if you have missed my previous session, so please go and check my description box and my first comment where the previous sessions links is already shared. Okay, so now move on to the next slide. So here we can see some subtopic which we will study. Okay, so first topic is estimation of the quartile deviation. We have already discussed the definition of the quartile deviation and its formula, but today we are going to explain the estimation or calculation of the quartile deviation. Okay, so now move on to the next concept, that is merits of quartile deviation, and last one, this is the demerits of quartile deviation. So at first we have to discuss estimation or the calculation process, and now going to the next topic, that is advantage and disadvantages of the quartile deviation. So learner, let's move on to the main slide and begin the session. So here we have already told measures of dispersion is of two types. The first one is absolute measures and relative. Second one is relative measures. Range, quartile deviation, standard deviation, mean deviations, all are under the absolute measures of dispersion. Okay. So we are going to discuss today the second type of absolute measures of dispersion, that is quartile deviation. Okay. So this is a slide for definition of the quartile deviation. So quartile deviation basically divides the whole series into four equal parts. That's why Q1, Q2, Q3 and Q4. So Q1 indicates the first quartile, Q2 indicates the second quartile, Q3 indicates the third quartile and Q4 indicates the fourth quartile. So at first, quartile deviation divides the whole series into four equal parts and measures the distance between the third quartile and the first quartile. So quartile deviation basically indicates the distance between the third quartile, that means Q3, and first quartiles indicate that is Q1. So that's why the formula of the quartile deviation is Q3 minus Q1 divided by 2. I think what do you mean by a quartile deviation is clear. So now move on to the estimation or calculation process of the quartile deviation. So move on to the next slide. So here we can see the first problem of the quartile deviation, and which is in individual series. Okay. So there are three series, basically individual series, discrete series and continuous series. So at first we have to discuss the individual series problem. Okay. So problem number 4. So the question is, from the following data relating to marks obtained by candidates in a competitive exam, estimate the quartile deviation. So numbers, so marks obtained by the candidates in a competitive exam, that is 100, 72, 45, 82, 91, 65, 62 and 83. So now I'm going to the solution of this problem. So here this is the solution for the particular problem. So for we are going to start the calculation process. So that's why the step 1 is arranging the data in ascending order. So at first we have to know what do you mean by a ascending order. So ascending means small, you have to arrange the all number in the series from small to large, big. Okay. So small number to big number. Clear? Now going to the second step, find out the values of the, this is first quartile and the third quartile, because formula of the quartile deviation is Q3 and Q1. So that's why find out the values of the first quartile, that is Q1, and third quartile, that is Q3, by using the following formula. So Q1 equals to size of n plus 1 divided by 4, and Q3 equals to 3 into n plus 1 by 4. Step 3 is calculate the interquartile deviation, that means Q3 minus Q1, and last step, that is calculate the quartile deviation by using its formula, because quartile deviation's formula is Q3 minus Q1 divided by 2. So now going to the problem, solution of this problem. Okay, so here we can here we are discussing only some steps to solve the problem. Okay, the first one, arranging the data in ascending order. Second, find out the values Q1 and Q3. Then calculate the interquartile deviation Q3 and Q1, and step 4 is calculate the quartile deviation by its formula. So now going to the solution. So here we can see the formula is Q3 minus Q1 divided by 2, and here from the data arranging, we have to arrange the data from from small to big in ascending order. So we are arranging the whole data in the series from small to big number. Okay, so that is in ascending value. So 45, 62, 65, 72, 83. So whole series follows the ascending manner. Clear? And the total number of values in the series, which is equals to 9. So that means n equals to 9. So what is the formula of Q1? That is n plus 1 by 2. So n means 9. So 9 plus 1 by 4, that, which is equals to 4, because quartile deviations divide into 4 equal parts. So that's why Q1 is equals to n plus 1 by 4. So n is 9. So 9 plus 1 divided by 4, that means 2.5 is the answer for Q1. And Q3, 3 into n plus 1 by 4, that means 3 into 2.5. So that means 7.5 is the third quartile. Clear? So what is the formula? So Q3 minus Q1. So 7.5 minus 2.5, which is divided by 2. So that is equals to 5 by 2, that means 2.5. So 2.5 is the answer of the first problem. Okay, so now going to the second problem, which is in discrete series. Okay, so the problem number 5 is calculate the quartile deviation of the following series. So salary 16, 14, 1200, 100, thousands and 600, and number of workers 9, 16, 21, 24. Okay, so now going to some steps. So here we can see the table, and there are 3 columns. First one is salary, second one is number of workers, and last one, that is a cumulative frequency and cumulative new addition to the problem, that is cumulative frequency. So you have already known what is the calculation process of the cumulative frequency. So if you have any doubt on it, what is the calculation process of cumulative frequency, so please go and check my description box and my first comment where the previous session link is already shared. So now going to the column of cumulative frequency. So the in the first class the frequency is 9. Okay, so this is the first class, that means the previous class frequency is 0, because 1600 is the first class. So that's why cumulative frequency is 9 plus 0, that is equals to 9. Okay, so now going to the second class. So frequency of the second class is 16 and the previous class frequency is 9. So that means the cumulative frequency of the second class, that is 16 plus 9, which is equals to 25. Now going to the 21. So 16 plus 21, that is equals to 46. 20 is the frequency of the fourth class, and the previous class frequency is 21. So that's why 46 plus 20, that means the cumulative frequency of the fourth class, that is 66. And now going to the last class here. So the frequency of the last class, so, that is 4, and the cumulative frequency of the last class, that is 66 plus 4, that means 70. So cumulative frequency, the last class cumulative frequency, so cumulative frequency of the last class is 70, and which is equals to the n. Okay, so n is 70. So we have already told the formula of the q1 and q3. So q1 is equals to n plus 1 by 4. So 70 plus 1 by 4, that means 17.75, which is equals to 18. And q3, that is equals to 3 into n plus 1 by 4. So that means 18 into 17.75 into 3, that means 53.25. Clear? So q1 is included in the which group? Sorry, 1 minute. So q1 is included in the second group. Why? Because that is 18. 18 is under this class, because 25 the cumulative 25 cumulative frequency. So 18 is under the second class, because the second cumulative frequency of the second class, that is 25. Okay, so the salary is 1400. Okay, so q1 is the 1400. Clear? And now going to the q3. So q3 is included in the fourth group, because 53.25 is under the this group. Okay, so 66. Clear? So q3 is equals to 1000. So qd, or quartile deviation, 1400 minus 1000 divided by 2, that means 400 by 2, which is equals to 200. So 200 is the correct answer for this question. So now move on to the next problem. So here this is the another problem of quartile deviation, and which follows continuous series. Okay, so now going to the problem. So here we can see the problem. So now move on the next slide. So here this is the calculation slide of quartile deviation in a continuous series. So the first step, we have to calculate the cumulative frequency of the problem. And now going to the second one, Q1 and Q3 items are located by finding out n by 4 items for q1 and 3 n by 4th items for q3. And now going to the step 3, so estimating the values of q3 and q1, and this is the formula of q1 and q3. Okay, so n is equals to, we can see this is total frequency, CF, that means cumulative frequency of the class preceding the class in which Q1 lies. L1, that means lower class boundary of the class in which Q1 lies. C means class size of the class, and F means frequency of the class in which Q1 lies. Okay, so now going to the solution. So here we can see the table, and there are 3 columns. The new addition is cumulative frequency. So the first cumulative frequency of the first class is 3, because there is no previous class. So that means 3 plus 0 equals to 3. So now going to the second one. So 3 plus 9, which is equals to 12. Now going to the next. So 12 plus 12, which is equals to 24. Now move on to the next one. So 24 plus 20, which is equals to 44. 44 plus 8, which is equals to 52. 52 plus 7, which is equals to 59. 59 plus 6, which is equals to 65. And 65 plus 5, which is equals to 70. So that means total frequency or n is equals to 70. So first step is we have to find out the n by 4 and 3n by 4 for calculation of the q1 and q3. So n is equals to 70. So n by 4, that means 70 by 4, which is equals to 17.5. So 17.5 is included in which group? In the third group. Okay. So 20 by 20 to 30, this is the class range, and 20 is the lowest class. Okay. So that's why for finding out the value of q1, that is formula is q1, so that l1, so l1 is equals to 20 because n by 4 is included in the third group. Okay, so between 20 to 30 marks. Now going to the formula. So here this we can see the n by 4. Okay, so n by 4 means 17.5. Clear? Now going to the previous slide. So CF, sorry. So now going to the CF. So what is CF? So CF indicates basically the cumulative frequency of the class preceding the class in which Q1 lies. That means CF is equals to 12. Sorry. Equals to 12. So 17.5 minus 12. Okay. So now going to the formula, divided by F. F means F is the frequency of the class in which Q1 lies. Clear? So, n by 4 is included in the third group. So, that's why this is the group, and F means 12. So, that's why 17.5 minus 12 divided by 12 into 10. Why? Because the formula is into C. Okay, so C means class size of the class. So size of the class 20 to 30. Class range is 20 to 30. So the size of the class, that means 30 highest class minus lowest class. So 30 minus 20, which is equals to 10. So that's why class marks is 10. So the value of Q1, that is equals to 24.58 approx. Okay. So now move on to the next slide for calculation process of Q3. Okay. So here we can see again 3n by 4, which is equals to 52.5 is included in the sixth group. Okay. So 52.5. Clear? So what is the value of L3, which is equals to 50? 3n by 4, which is equals to 52.5. Frequency is 7, and the cumulative frequency, which is equals to 52. So now going to the next slide. So here we can see the value of Q3 equals to 50 plus 52.5 minus 52, which is divided by 7, which is equals to F, and into 10. So that means class size of the class. So 50 to 60. So 60 minus 50, which is equals to 10. So that's why C is equals to 10 for this problem. So the value of Q3, which is equals to 50.71 approx. So we have got the value, we got the value of Q1 and Q3. And now going to the quartile deviation. Okay, so formula of quartile deviation is same, Q3 minus Q1 by 2. So 50.71 minus 24.58, which is divided by 2, that means 13.06. So 13.06 is the answer of this problem. Okay, so I think this is clear. So if you have any doubt on it, so please feel free to ask, and please do comment in my comment section. I will reply you. Okay, so now move on to the next slide. So here we can see some advantage or merits of quartile deviation. So first point is quartile deviation is easy to understand and simple to calculate, and we have already uh, told that thing because it is very easy to understand and it is very simple to calculate it. Its calculation process is very simple. So now move on to the second advantage, that is it is not affected by the extreme values. Okay, extreme values basically it is based on all observations. Okay, so now move on to the third one. Quartile deviation can be used in measuring variation of the open-ended distribution also. So which is one of the most important advantage or merits of the quartile deviation. And this measure quartile deviation is useful when it is desirable to know variability in the central part of the data. So I think this is clear what is the basic advantage or basic merits of the quartile deviation. It is not affected by the extreme values. Quartile deviation can be used in measuring variation of the open-ended distribution. It is very easy to understand and simple to calculate. So now going to the next slide, and here we can see some demerits of the quartile deviation. So the first one is quartile deviation is not rigidly defined. In the case of number of observations being such n by fourth or n plus 1 by fourth is a fraction. So the first and third quartiles are estimated only the approximately. So that's why this is not rigidly defined. Okay, so now going to the next point, it gives a measure of spread of middle 50% of the observations, and it is not based on all observation. So it is not affected by the extreme values, and it basically it gives a measure of spread of middle 50% of the observation. Okay, and it is not capable of the further algebraic treatment also. So it is easy to calculate or easy to understand, but sometimes it is not capable of further algebraic treatment. Okay, so that's why it is one of the most important demerits of the quartile deviation. So, learner, we are done for the today's session. So, I think it will be very helpful to everyone. So, I will come again with an exciting session. So, till then, stay tuned. But if you like my session, so please do not forget to like, share, and comment. And please do some support and subscribe to my channel, and you can press the bell button for getting new notifications from my side. Happy learning. Thank you.